So here we're going to do the discrete probability distribution. This lists each possible value of the random variable along with its probability of occurring. So it must satisfy the following conditions, and there's two of them. Number one, each probability is restricted between 0 and 1. Okay? This is for each value of the random variable x. Okay? Number two, when I add up all of the probabilities, so I add up all the probabilities over all the values for the random variable, it should add up to 1. Okay? So why do these rules make sense? Okay? Number one, if I'm talking about probability, the smallest your probability can be is 0. If it's a 0 chance of happening, that means you're for sure it's not even possible. And the biggest your probability can be 100%. And if you have 100% probability, that means it's a certain event. It's going to happen, guaranteed. Can't be any bigger, can't be any smaller. The other thing you think about is if you consider all the possible things that can happen and you add them all up, it should add up to 100%. Okay? When you add up the sum of all the probabilities is equal to 1, which is 100%. Okay? So that is the idea for a discrete probability distribution. We have to satisfy these two things for it to be a discrete probability distribution. So what I'm going to do is I'm actually going to take this example and we're going to make a discrete probability distribution. Okay, so let x be the number of children in a family. Okay, use the frequency distribution to construct a probability distribution for x. We're going to graph the histogram and we're going to verify that it's a probability distribution. So here it is. So x, okay, and then f for the frequency. So 11 people have no kids at all. X is the number of children in the family, right? 32 people have 1 kid. 39 people have 2 kids. 10 people have 3 kids. And then 8 people have 4 or more kids. I say 4 plus. For our purposes for this problem, we're just going to say that 4 plus is equal to 4. Okay, so technically it's not, but so we can work this problem, we're going to assume that 4 or more we're just going to count that x value as a 4. Okay, so first thing that I want to do when I see this is I want to figure out how many people did I go out and survey. So I'm going to sum up all the frequencies, and if I add all these up, I get 100, which getting 100 is very helpful because whenever I go to calculate the probability is just the relative frequency, okay? The relative frequency, since it's equally likely. And so that means that's 11 over 100, which is 0.11, 32 over 100, which is 0.32, 39 over 100, which is 0.39, 10 over 100, which is 0.10, and 8 over 100, which is 0.08. Now, what I want to do is I want to construct a probability distribution. So what is a probability distribution? Okay, it lists each possible value along with the probability of the value occurring. So here's each possible value and here's the probability of it occurring. So we have to calculate the value. So the probability distribution of x is the values and the probability of the values happening. So the first value is 0, and it has a 0.11 chance of happening. Okay, right there. The next value is 1, and it has a 0.32 chance of happening. The next value is 2, and it has a 0.39 chance. Then 3 with a 0.10 chance, and then 4 with a 0.08 chance. Okay, so broken up using this table. So that, my friends, is a probability distribution. Now, I want to graph the histogram, excuse me, and then I want to verify it's a probability distribution, okay? So first thing I'm going to do is I'm actually going to verify that it's a probability distribution. There's two things. Number one, all the probabilities have to be between 0 and 1, okay? So what are my probabilities? Well, the first one is this one right here, okay? So P0 is equal to 0.11, okay? Probability of getting a 0 is 1. Probability of having no children is 0.11, right? Probability of having one kid is 0.32. Probability of having two kids is 0.39. Probability of having 3 kids is 0.10. And the probability of having 4 kids or more is 0.08. Now, what do I know about those probabilities? Each is between 0 and 1, okay? Meaning each of these, okay, is between 0 and 1. And so this is what I'm looking for when you write out your solution, okay? So that's what I'm looking for to verify the first step, okay? The second step, the probabilities have to add up. So what do I want? At a minimum, I want you to add up all the probabilities. 0.11, write it out. 0.32 plus 0.39 plus 0.10 plus 0.08. If I add those up, okay, what should it equal? Well, what does it say it should equal to? It says it should equal to 1. Okay, if I add them up, I get 1. All right, that's the other thing that I want to see written out on your paper. If you want to write P of 0 plus P of 1 plus P of 2 plus P of 3 plus P of 4 equals 1, and then write this other line too, that's fine. But at a minimum, you got to write this here, okay? So this is your minimum, okay? You get those two things, you get it right. All right, so that verifies that it's a probability distribution. Each one of those are between 0 and 1, and then when I add them all up, it adds up to 1, okay? So let's do a couple more where we determine if they're probability distributions. Actually, let's graph it first, because we did say that we wanted to do a histogram. So to graph this is not too bad. If I graph this, all right, I'm going to have my probability on the y-axis and my value on the x. So 1, 2, 3, and then 4 more. So the first one is at 0.11. And then we go up to 0.32. And then we go up even higher to 0.39. And then 0.10. Oh, what about that? Okay, now I messed this up. Okay, I need to do one more over. Hold on 1 second, guys. So this needs to be like that. And so the 0 is the first one. And then the last one is 0.08. Okay? So that would be the histogram. All right, so there's my histogram right there. And if you want to shade those, you can, but there's no reason to shade them. You can just draw it out. Okay? So the y-axis is the p of x, and the x-axis is your random variable, the different values of the random variable. Okay? Now, if I was going to go a little bit further with this and do a little bit more practice, so let's determine if each distribution is a probability distribution. Okay? So you gotta have the probabilities stuck between 0 and 1. That's number 1. And number 2 is when you add up the probabilities, they have to add up to 1. Okay? So those are the two things we're checking. So when I look at this one, if I check these, every one of them are between 0 and 1. So number 1, check. Okay, does it add up? Okay, does it add up? Well, number 2, if I added up 0.28 plus 0.21 plus 0.43 plus 0.15, when I add all those up together, I get 1.07. Ooh, that's not equal to 1. Therefore, not a probability distribution. Okay? Now, sometimes guys, when you add these numbers up, it's going to get you like 0.999 or like 1.001 or 1.002, something like that. When it's this close, when it's close like this, the reason that you didn't get exactly, oh my gosh, exactly 1 is because of a rounding error. So like if you're like this close, then that's going to be okay. Okay? But if you're off by like that much, that's definitely telling you there's something wrong going on. Okay? So when you're showing that it's not 1, then all you got to do is prove one of them. We don't have to write out everything that needs to be written out for the first part if it's not 1. So first thing I do is I just check to see if it even is 1. In the next one here, I've got probabilities all right here. They all look like they're between 0 and 1. If I add them up, 1/16 plus 5 over 8 plus 1/4 plus 1/16. Well, let's see. Common denominator is 16, so that's going to be 10 over 16 plus 4 over 16 plus 1 over 16. 1 and 1 is 2, and then 4 is 6, and then so 10 gets me 16 over 16, which is 1. So this adds to 1, okay? So that's number 2 satisfied. Now, what else do I know? Probability of getting a 5 is 1/16, and that's less than or equal to 1, but greater than or equal to 0. Probability of getting a 6 is 5 over 8, and this satisfies. Probability of getting a -7. Oh, wait. Can I have a negative number here? Is that okay? Absolutely, it's okay to have a negative value. What you cannot have is a negative probability. That's what we're looking at. So don't let that throw you off. If you see a negative value, it's the probability that's got to be between 0 and 1. Okay? So the probability here is 1/4, which is between 0 and 1. And the last one is probability 8, which is 1/16, which is clearly between 0 and 1 here. So now we've satisfied yes, probability distribution. Okay, why? Because we showed this here, and we showed this adds up to 1 there. Okay? This last one here, I look at this. Are all the probabilities between 0 and 1? Looks like P of 4, when I plug in P of 4, I get -1. Well, that is not between 0, and 1. Okay? So P of 4 is actually less than 0. Right? Therefore, not a probability distribution. Okay, there's no reason to keep going on to see if it adds up. I mean, you could, but there's no reason to do this work if you figure out right here that it's not telling the truth, that it's actually not a probability distribution. Why add everything else up? And by the way, if you add this up, you're actually, let's see, if I add this up, what does that equal to? That would be 2/4 plus 1/4 plus 5/4 minus 4/4. So that would actually equal, well, that's tricky. That would equal 1. Okay, so that's no bueno, right? So if you look at that, you might think, oh, well, it all adds up to 1. But the problem comes into play because you're adding a negative probability. And there's no way you can have a negative 100% chance of something happening. That just sounds goofy, even saying it out loud. So that's how you verify probability distributions. So hopefully you've got a better idea of what a probability distribution is. All it is the values in a table and then the corresponding probabilities that go with those values. That's it. That's all there is.